Natalia, and very happy to see you again after such a long time, and very happy to have you here for this interview.
Hello, Sabino. Very nice to catch up with you.
Yeah. So let me jump immediately to the questions. And what I want to start with is actually your data science journey. Where did it start? How did it start? Why did it start? And where are you now? And if it was an easy path for you, or there was some difficulties, especially your gender, did it make any problem along the way?
Okay, so when I studied computer science, I wasn't really sure that I would like it. So I knew I like physics, I like math, so I like a lot both of them, but maybe not enough to just study physics or just study math. So I thought this is another field, and I don't know much about it, so I want to know more. So I was very curious, and the more I learned, the more I liked it. The more I thought that it's a very useful tool, and then I got interested in artificial intelligence and see that you can do a lot. You can predict stuff, you can automate stuff. So it was like giving you a lot of power, right? So the more I learn about it, the more I liked, and I feel like it's very powerful. When we started, we were 30 women out of 100 in my promotion at the University of Granada. So that was like, wow, a
Oh,
lot,
that's a good
lot
ratio,
of
if you ask me,
girls.
even today. Yeah.
Yes, 30 girls out of 100 was like crazy, like so much for computer science. So I think we were a really good promotion, and I say very good memories from those times. Um, and I think it made it also very nice for our promotion. We were very cohesive, and diversity helped. I remember in Finland when I did my Erasmus, there was much less women, and
Mm.
in general, when I've been abroad, there is always much less women. So I think in that sense, we were lucky, and it was a good ratio that I'm not sure it really repeated again. And in terms of gender, other than that, there are recent stories of women feeling harassed, maybe in men-dominated communities or fields like it's computer science. But honestly, I've never experienced any of such a negative experience. So I hope that this is still a vast majority, and that we don't let these cases happen.
Yeah, definitely so. Thank you very much. Let's get to your professional interest. And recently, I've been working a lot on explainable AI, and explainable AI has gained a lot of attraction. But probably the term is not still clear for many people. They know this is some new trend, some new scientific field, but still, many don't know what is this. How you are defining explainable AI, and at the same time, why there was a need to have such a field.
Okay, so yeah, many people think it's a hot topic. It indeed is a hot topic right now, but precisely I think it's because we are in the era of the deep learning hip, let's say, like it's very hot. We are doing a lot of advances with deep learning, and it's very cool, but we don't really always understand when these models work, or when they break, why they break, or when they work, why they work, and then you change something small and they don't work. So I thought that this will be the great way for me to better understand how these models work. So basically, explainable AI is a suite of machine learning techniques that produces more explainable models, or maintaining ideally high performance. Ideally, we don't want to compromise this performance, although we know that there is some trade-off sometimes between explainability and performance. But the idea is to enable humans to understand, trust, and also manage this emerging generation of artificial agents. And explainable AI also draws insights from different disciplines, also from social sciences, from the psychology of explanation. The conversation can become really philosophical. However, in my case, we want to stay at the technical level and tightly coupled with the models, so that we can produce explanations that actually look at interface as a way to communicate between the decision maker and and humans, regular humans. So the idea is that explainability is associated with the notion of an explanation as an interface between these humans and the decision maker, and they should be, this explanation should be an accurate proxy of how the model is working, and also convey this meaning that is expected by the audience. So we recently wrote a survey on explainable AI and responsible AI, because we believe it's a medium to achieve responsible AI and ethical AI, where our main contribution is that we say that explainability is very much depending on the audience. So given an audience, once we fix it, we will have that an explainable artificial intelligence is one that produces details or reasons to make its functioning clear, more easy to understand. So once we have defined this audience, we will be able um, to convey and to assess if this explanation is enough or fulfills this purpose to explain the output, which is much more concrete, let's say, than just the mere understandability of a model or the comprehensibility, which perhaps stays at a more generic level.
So let me develop on the same in the final words that you said, that it is important to fix the audience and then we do the explanation. But what you are saying means that we can explain anything and everything, just we need to know what is it that we want to explain, or there are still some limitations to the things that we could explain.
Yeah, so that's a very good point. Like at the moment, like the methods on explainable AI, they are mostly tailored for images, image-based models, or not so much on text models, even though deep learning models mainly target text or images so far. So we can explain in terms of pixels or regions what are the areas of a subset of pixels that actually react and the most for a given output or contribute the most to a given outcome of a model. So these are all local explanation. It's very hard to find generic or general non-local explanations that will account for the overall functioning of the model, and not just looking, okay, tell me why, given this input, we have this assigned output. So many authors argue, and we ourselves also argue in our article and in our current work, that explainable models is the task of finding relationships between the model and the outcome. But what we actually need to test is for actual stronger links, which are going to be causal and not just correlational. And this should involve the variables that we care about. So this is an area that is also very hot, but it shows that there is still plenty to do, because our explanations are very easily full. There's an article saying that saliency maps like basically show gradient-based activation maps. It might be a red herring, because there are many variations and they are not explainable in terms of symbols or concepts that we humans actually convey explanations with. This is the area where
So we need somehow to explain the explanation, because this is not necessarily in the human level terms how to explain a model. We get something, but we still are not there to explain the explanation somehow.
Yes, but I believe that the explanation should be as close as possible to what a non-technical users should expect. And if we look at a non-technical user, then we look at experts. If we have medical a radiologist, for instance, trying to make sense out of our X-ray image to process if the lungs have COVID or just other kind of pneumonia, the expert should agree with the explanation that we give, and we want the explanation of our model to actually be close to the one of the expert. So I think language is the most universal way to convey this, and I advocate for language-based explanations. But we need to link this to every component of the model in a semantic and but also neural and symbolic way. And yeah, so this is where we're working. There are still many challenges to do. So yeah, happy to get collaborators and ideas on this.
Yeah. Uh, you said there are challenges, and this is actually what I wanted to ask next. That are we still in the place that we are given a machine learning model, and then we could explain why it made the decision it made? And if not, what are the bottlenecks? Why we are not there yet?
So there's plenty of pitfalls. For instance, in the example of the COVID, there are some interesting studies that actually they show that a model that classifies, giving a picture of the two lungs of the COVID image, if you put a black patch in the middle, the accuracy model drops only from maybe 70% to 60% accuracy. So this is very worrying. This is very disturbing because it means our model is actually not paying attention where the COVID or the pneumonia should be observable, which is inside the lungs. So this is quite disturbing, and this tells us that there is something wrong. Our networks are learning some noise, they are learning some other correlated signals that are not exactly what we would expect. So definitely there are many intricacies and bottlenecks that it's where we need to put our attention, I believe.
Uh, Good. And from what you're saying, we kind of need explainable AI so that we could make sure that the models that we are building are trustable and reliable. So we understand why the decisions that they are making make sense in another way. But then explainable AI is yet another model. How do we trust explainable AI outcome or explanation, or how you want to put it? How do we trust this, the tool that we are using to trust something else?
Yeah, so this is a very good point, and it's something there is not enough work. It's not as hot as counterfactual explanations and causal explanations, but it should. This is something that we, in our group, we have been discussing the needs for validation and verification of neural networks from the point of view of formal models, because these communities are somehow not connected enough, even though we usually have in our lab people doing this. In the end, we don't find the common language, the common interface to actually mix these two, and this will be really needed. So we want to certify a model. Once I create a model, I want to certify and say to the patients, like, would you like to try? Like, maybe it can save you a few days of waiting your appointment to the doctor. It's not as trustable. It's maybe 70% accurate, but at least maybe can give you some estimation your of your symptoms, right? Like, should you be quarantined at home, or should you probably be fine and you can still go out, right? So I would like to emphasize the needs for unit test for neural networks. I like this term. I was discussing at branch with some friends from ML community, my friends in Paris. I like this term. I think it's really good that we are not really doing unit tests on models. So we should apply the same software engineering verification and validation methodologies to set a bunch of cases that we expect to be accurate and correct, and a minimum set that should certify somehow the functioning. So this is another area that we should work on if we want to deploy these algorithms.
Yeah, I totally agree with you. And now we talked about the concept of explainable AI. Do you have any interesting example of the application of explainable AI? It's something that you heard about or you did yourself?
Um, I think the most interesting case, perhaps people know, it's like how when you have a classifier that you want to not classify cats and dogs like normally, but maybe distinguish. You want to teach different race of dogs or huskies huskies and dogs. There was this case that just show how easily neural networks get full. Like they might get very, very accurate, 99% distinguishing a husky from a dog.
Mm.
But if you actually look at where the network is paying attention to what pixel is actually attributing this output, you will actually look that this study showed that it was just basically looking at the background, because the husky is always behind in front of snow, so the background is always white, and the dog is normally in green grass in your park. So actually that was actually what the network was looking at, not actually the features of the actual dog. So this is a funny example, but very eye-opening, I think it was, for showing how or changing just very simple pixels with adversarial examples, which are called, we can completely change we can predict that there is a monkey when there is a dog. So
And this
this is very
indeed is a
intriguing. And
very yeah, this indeed is a very
sorry.
I was saying that this indeed is a very interesting example because at the end it's not only the machine that we put the blame on, it is human being, because we are given the data set that is uniform in the background. In the front there are much more difference, so as a machine, so that is what is happening in every picture, so this is what it's going to learn. And explainable AI has been good in the sense that it helps us remedy our ways. This is what we're doing probably is not right, how we're producing the data. We should be more careful about what we are feeding to the algorithm, basically. That was really interesting example. It was a very fascinating topic that we discussed, but talking about all these AI things, and we try to understand AI, and we try to make AI algorithms smarter with helping them basically by doing this explainable AI. The question that comes to mind is that could we get to the super AI stage that AI products AI products outperforms the human beings, basically. They do better than we are doing. Is it possible, in your opinion?
I hope so. That's enough so that we get a much more productive life, and they generate the vaccinations we need for us for the next viruses. So I hope so. But unfortunately, I think we are a bit far, but we are getting there slowly. So there are some fields, for instance, in ophthalmology, in retinopathy. The Google Brain team has shown, I think, that in this particular case of retinopathy from images in the eyes, they can beat the accuracy or reach similar levels to an expert. So this is very good news. Also, with cardiologists, there is some cardiologist score with my collaborators from University of Granada. They are annotating the data because what we advocate is that these annotations need to come from the expert. So in order to have models that can beat the expert, we need to also have explanations that agree with them. And in some cases, they are reaching very close to the accuracy of expert, but it's also very intriguing. For instance, in a case with a startup I collaborate that is for psychotherapy, experts don't agree. So it's also hard to get neural networks to agree if even experts diagnosing a person don't agree, right? So I guess here we also have to account for that.
Yeah, but still the progress that has been made is quite outstanding, and
yes,
the more forward we go, the pace is going to be faster, and who knows, probably in probably a few days, but a few years, but probably some decades, we get to the place that robots, as you said, take loads from human beings' shoulders. Thank you very much, Natalia, for the very interesting discussion. And it was really nice having you here. I wish you good luck in all your research and the things that you're doing. And I am sure what you're doing is going to be very impactful towards society. Thank you very much.
thank you so much, Sepino. Thanks a lot for inviting me and for this great initiative that you are doing to have more women in data science. I think it's very good.